Circular permutations. The permutations of things which can be represented by points on a circle are called circular permutations. Let us consider four things A, B, C, and D. Let A, B, C, and D are four objects to be placed around a table. What are the possible arrangements? If A is seated here and B is seated here, C is seated here, and D is seated here, then this is one permutation and it's one possible arrangement that can be made to let A, B, C, and D sit around a circle. But if we change the position of A in such a way that A is here, B is here, C is here, and D is here, although A has moved one place toward left, but relative position of ABC didn't change. So we cannot say definitely that it's a new permutation. It's similar arrangement because the relative position is still the same. Similarly, if A is seated here, B is seated here, C is seated here, and D is seated here, again this is similar arrangement because the relative position of A, B, C, D is still the same. And if A is seated here, B is seated here, C is here, and D is here, again the arrangement is same. So all these four arrangements of seating A, B, C, and D is in fact called one permutation. Therefore, the total number of permutations, the total number of permutations are circular permutations. Permutations would be equal to 4 factorial, just like before, divided by 4. Now this divided by 4 means because 4 of the arrangements which we otherwise counted while we were making linear permutations are now considered as one permutation. That's why we divided it by 4, because 4 arrangements in fact make one permutation. But if we were to make linear permutation, suppose A, B, C, and D were to be placed on line. Suppose A, B, C, and D were to be placed along a line. If that was the case, then by placing A, B, C, and D, if we move A toward right, here this would be A, this would become B, this would become C, and this would become D. This is certainly not the same arrangement because now the relative position is not the same anymore. That's why these two are called different permutations. And similarly, if A goes here, B goes here, C is here, and D is here, That's still another permutation. And similarly, if A goes here, B is here, C and D. Although we have moved A each time by one place, but it still gives rise to a different permutation. It's not the same arrangement because the relative position has changed in case of linear permutation. But in case of circular permutation, by moving by one space, it gives the arrangement which are necessarily same because the relative position does not change. That's why in circular permutations, we have the total number of permutation equal to 4 factorial by 4, which can be in fact written as 3 factorial because 4 factorial means 4, 3, 2, 1 divided by 4. So this 4 gets cancelled with this 4, which gives us 3 factorial. But in case of linear permutations, the total number of permutation in case of linear permutations are when the objects or things are arranged on a straight line. In case of linear permutations, number of permutations as we have studied before is equal to 4 factorial. So this gives rise to a formula that circular permutations are equal to linear permutations of n objects. If the total number of objects is n, then divided by n. That would be the formula. So let's do a few questions in order to illustrate the concept of linear and circular permutations. So for first question here, it says, how many ways can 6 people be seated together? In how many ways can 6 people be seated together along a table or a circular table? So if that is the question, then the number of arrangements, so example 1, if 6 people are to be seated around a table, then circular permutation, number of circular permutations would be equal to 6 minus 1 factorial. So that would be equal to 5 factorial, which is in fact equal to 120. In second example, Now the example second says that find the number of ways in which 5 people A, B, C, D and E be seated around a table such that A and B must sit together. So out of 5 people A, B, C, D, if A and B are to sit together, then we will consider A and B as just one object. If A and B must always sit together, then consider A and B as one object, So if that is the case, then number of objects will be 4 instead of 5. So the number of objects is equal to 4. Thus, required number of permutations, required number of circular permutations, is equal to, if these are 4 objects, then the number of permutations would be, of course, 4 minus 1 factorial. So that would be 3 factorial. But because A and B can alternate their position while being together, like we can write AB or BA, that's why we will multiply this by 2. So this would be equal to 3 factorial means 6 times 2. This is equal to 12. In next example, the second part, example 2b part, it says that C and D should never sit together. If C and D should never sit together, then how we are going to achieve? Let's first find the total number of circular permutation for seating 5 objects A, B, C, D and E along a table. If C and D, first find total number of circular permutations. For seating 5 objects, that would be equal to 4 factorial, because total number are 5, therefore the total number of circular permutation would be 4 factorial, and 4 factorial is equal to 24, because 4 times 3 times 2 times 1. So this is 24. And as we did in part 1, the total number of circular permutations in which C and D are together. So how many were those? Just like A and B in part 1, those were 12. Thus, thus required number of permutations in which C and D are not together is equal to 24 minus 12, and therefore that answer should be equal to 12. And now the last example for this lesson is that in how many ways can 3 men and 3 ladies be seated at a round table such that no 2 men are seated together. So for solving this kind of question, let's first arrange for 3 seats for women. Example 3. If 3 ladies are seated on alternate chairs, so that the 2 ladies are not together. There is a 1 seat in between 2 ladies where a man could be seated. If 3 ladies are seated on alternate chairs, then the number of circular permutations is equal to 3 minus 1 factorial mean 2 factorial. So there are only 2 ways. But once these 3 ladies are seated, now there is 1 chair in between every 2 ladies. Now there are 3 factorial permutations for men to be seated on alternate chairs. The reason is that this permutation for men is not circular anymore. The reason being that it is linear permutation for seating arrangements of men. Because if men were to change their position by 1 chair, actually it wouldn't be by 1 chair, they would be switching over 2 chairs, and those arrangements will be a new permutation. Those alternate arrangements will not be the same kind of arrangements. That's why this permutation will become linear now. Thus the total number of ways, so permutations to seat 3 men and 3 ladies or 3 women. 3 women in a circle are equal to 2 times 3 factorial, and that would be 2 times 6, that would be equal to 12.